Bismillahirrahmanirrahim. So this process is the interaction of positron with the matter, or the loss of energy, or you can say the process of the annihilation. This is the way how this is going to lose its energy. So positron, let's suppose this is the parent, and it is going to converted into daughter with the emission of the positron. So positron is having a short path length. Here you can see this is the between zero point 0.1 millimeter to some millimeter. So it disappears following its interaction with the electron on its way. So positron mean having the positive charge but having the same mass as the electron is having. So this is the atom, and the atom is having the extra nuclear part. That means the electrons is present in the K, L, and M shell. So this is going to interact with the radiation. So being the short or this the small range, it disappears following its interaction with the electrons on its way, and this process is called the annihilation process. That means when it is going, the positive is going to interact with the negative, this is going to annihilate, and the process is called the annihilation. And when they are going to interact, that means positive and negative charge, they are disappear with the emission of the two gamma rays. That means two gamma photons are generated with an equal energy of 0.51 mega electron volt or 511 kilo electron volt. So this is the process of the interaction of positron and the loss of energy with the process of the annihilation process. So this is very simply is mentioned over here. This is the positive, negative, and they are going to interact. They are annihilated with the formation of the two gamma rays having the energy of the 0.51 mega electron volt. So where the 0.51 mega electron is coming out, and this is the very simple example over here, and this is another example. That means this is the parent carbon 11 with the when it emits the positron. That means there is the positron, there is a decrease in one atomic number, and there is no change in the mass number. The mass number will remain the same with the emission of the positron, and this positive electron will interact the electron present in the outer shells with the emission of the two photons or the two gamma rays. Each one is having the 0.51 mega electron volt or 511 kilo electron volt. So actually positive and negative positron, the electron, they are annihilated with the formation of two gamma rays. Total energy is 1.022. That means sum of the point five and 0.511. So this is the how you can convert the mass into the energy. This is the mass of the electron, 9.11 x minus 31 kilogram, and you may convert into the gram, 9.1 x minus 28 gram, and you can multiply with the Avogadro number, and you can further multiply 931.5. This is the one unified mass. You can directly convert the mass into energy by multiplying 931.5, and you will get the value of 0.511 mega electron volt, or further you can multiply with 1000, it will convert into 511 kilo electron volt. So sum of the two uh, gamma rays, it will produce the energy of the 1.022. So this is another way uh, for the interaction of the radiation, and this is actually called the electron capture. And the process, you have already learned these process from the different videos at the start of this course. So here with the electron capture, this is similar to the positron emission in a sense. In the both cases, there is the a decrease in one atomic number, and there are several other differences I have explained in the previous video. You may watch again, but here I'm going to discuss what are the processes associated with the electron capture. So what is this? This is the nucleus, the electron present in the K shell. This is captured by the nucleus. This process is called the electron capture, and there is the by capturing this one positive is less. That means one proton is converted into the neutron, and there is the vacancy is created over here in the K shell, and there are the electron present in the L shell. They are coming towards the K shell from high energy to the low energy, and the difference in energy is lost in the form of the X-ray. So this X-ray, one of the process is associated with the electron capture, and this is called the X-ray emission. So this is the way how X-rays are generated. So again, now the vacancy is created, the electron is deficient in the second shell. So with the emission of the X-ray, if this X-ray is having the sufficient energy to further remove the electron from the outer shell, because from the, let's suppose from the M shell, these electrons are called the Auger electron, and this effect is called the Auger effect. So this Auger electron or the Auger effect is associated with the X-rays produced from the innermost shell, electron moving from the L shell to the K shell, and if it is having sufficient energy to further remove the electron from the M shell, this process is called the Auger effect, and the electrons are called the Auger electron. So this is the process. X-ray emission or the Auger effect is associated with the electron capture. So in this video, actually, we have covered in the several few previous videos. We have covered the interaction of the particle, alpha particle, negatron, positron, and the electron capture with the matter. And in the next video, we will discuss about the interaction of the gamma ray, which is the photon, with the interaction of this radiation with the matter.